Good morning, Year 12, and this is the second lesson on the Poisson distribution. And in today's lesson, we're going to focus on how we can calculate cumulative probabilities without having to add them individually. So, back when we did the binomial distribution, I showed you where to access the information to find the tables for the binomial distribution. We can also use the Poisson distribution tables that are in the booklet as well, and it's the snippet I produced here is on page 6 of the tables booklet, so it's only a brief part of the tables. There's far more information than this, and as you can see in this table here, the values for lambda. So if we remember that if a random variable for x follows a Poisson distribution, then lambda is the mean number of times it happens. So these values here at the top, the 0.1, the 0.2, are the values for lambda in each case. As you can see, once it gets to 1, it then jumps in 0.2s. So if you wanted to work a Poisson distribution where lambda was 1.1, you would need to revert to the calculator to solve those sorts of problems out. The values on the left here are the probability that x will be equal to 0. If it comes to the 1 in the table, it's the probability that x is less than or equal to 1. So therefore, the combined probabilities of x being equal to 0 plus the probability of x equals 1, for example. So just a quick example then to start us off with, just to get us back into the swing of things. This one says a typist on average makes 3 typing errors on a single page. We have been asked to use a Poisson distribution to calculate the probability that on a single page, the typist will make 2 errors. So if we call the random variable x the number of errors on a page, then it will follow a Poisson distribution with lambda equal to 3, the average number of errors on a page. The probability that the typist makes 2 errors is really asking us to work out the probability that x is equal to 2. Now, we can use our calculators. There's only one probability that we need to work out, or we can use the formula more easily on this one. So it'll be e to the minus lambda, which will be e to the power of minus 3, multiplied by 3 lambda to the power of x, which x in this case is 2 errors, all over 2 factorial. And typing that in like we did last time on the calculator will get you 0.22404 and so on. So rounded correctly to 4 decimal places, we get 0.2240. And if I revert back to the tables on the previous page here, you will notice that all the probabilities in this table are all given to 4 decimal places. So let's have a look then at the next part of this question. Part B is asking us for at most 4 errors. That's up to and including 4 errors. So for part B, we actually need to work out the probability that x is less than or equal to 4. It could be 0, 1, 2, 3, or 4 errors. So there in itself means that we would potentially have to work out 5 separate probabilities and put them together. Well, there is a far easier way of doing that, and we can either use our calculators in order to do it, or we can refer to the tables. So if I show you how to use the tables here, part of the tables you would need to find where lambda is equal to 3.0 in the tables. We wanted on this one the probability at most 4 errors, so the probability that x is less than or equal to 4. And as you can see, I've drawn your attention to it here in this table, that it's 0.8153. So 0.8153. On a calculator, so you need your calculators with you now. All right, so on this calculator then, once you turn it on, you need to press the menu button. You need to select option number 7, and you need to arrow down. You need to select, this time, option number 3, which is the Poisson CD, so cumulative distribution of probabilities. Then you need to select 2 to input your variables. X is the number of times we want to work out for how many times something happens, and lambda is the parameter, so your average number of outcomes we expect. So given the data that I've just got, this is how it looks on the calculator. So I've typed in that lambda is equal to 3, and we want 4 in there for 4 and below. That includes 4. When you press equals, it gives you this solution here. And to 4 decimal places, we would have to cut it off there and use the 6. So we would be rounding that up. So the 2 would round up to a 3. So 0.8153, which, as you can see, is what the tables show. So there's the 2 possible ways of actually using our tables and the calculator. What about part C then? What's the probability that we get more than 6 errors? What does this mean? Well, more than 6 really implies that it's got to be 6 or above. So more than 6 would imply to me that it includes 7 or above. So it includes 7 and more. But these tables are only for less than or equal to probability values. So we need to think, if we want 7 or more, what don't we want? Well, we don't want 6 or less. So everything would be 1, but we don't want the probabilities up to and including 6. So if we subtract that away from 1, it will give us the probability for more than 6 errors. So again, now we can use the table here. So if I can select where it's 6, then I'm looking at this value here, 0.9665. So from that table there, I can do 1 minus 0.9665 to get my solution. So giving me an answer of 0.0335. Again, go into your calculator, you could type that in. Your x value would be on your calculator 6, and your lambda would be 3. And again, rounded correctly to 4 decimal places, again, it will give you the 0.9665. Okay, example 2 then. The number of calls to an emergency number has a Poisson distribution with a mean of 1.2 calls per hour. We are being asked to calculate the probability that in a 2-hour period, there will be less than 4 calls. So this average then is per hour, and we are being asked to do it over a 2-hour period. So we need to adjust our variable so it follows a Poisson distribution over a 2-hour period. So we need to double the average. So we're doubling 1.2 to 2.4. Okay, the probability that there are less than 4 calls, well, less than 4 is 3 or below. So what we really need here is to find the probability that x is less than or equal to 3. And again, you can go to your calculator or you can use your tables on this one for 2.4. There we go. Here's a snippet of the tables again. You can find it. There's 2.4. So we're in this column here with the arrow. And for 3, we need to be across here. So we're going to be selecting this one here, or you can get that value from your calculator. So 0.7787. At least 5 calls. So that means we want 5 or more. So in this case, we want 5 or more. And again, we can't use the tables for 5 or more or calculators. It only works for probabilities less than or equal to. So what don't we include in 5 or more? Well, we don't include 4 or less. So in other words, we want to work out what the probability of having 4 or less and then taking that from 1. So again, I'm just using the tables from on the page opposite, on the next page. So less than 4 would be, in this case, 0.9041. Or again, you can use your calculator to work out these values. So I'm going to use 0.9041 from the tables. And working that out gives me an answer of 0.0959. Part C then, what's the probability that we get more than 1 call but less than 6? So more than 1 but less than 6. What can we have here? Well, If you want more than 1, that's 2, 3, 4, 5, and less than 6. So they're the probabilities that we need. So we can work out those 4 individual probabilities and add them up separate, or we can work out the probability that x is less than or equal to 5. So that's 5 and below. So this time that's 5 and below, but the ones we don't want in this case are 0 and 1. So we want to get rid of then those probabilities for 0 and 1. So in this case, then again, we can go and use our tables or our calculator, and we can work these out. So the probability that x is less than or equal to 5 is 0.9643, and the probability that x is less than or equal to 1 is 0.3084. Again, and just some simple work on the calculator will give us a final solution of 0.6559. All answers correct to 4 decimal places. Okay, what I would like you to do now is the main task. So make some notes on what you've just been seeing. The main task is as part of the assignment is called Poisson distribution CD, and have a go at those questions. And once you have a look at this checking question, have a go at it, and I will be posting out some solutions to these questions in the early part of next week so that you can check over all of your work that you're doing at home. I hope this has really helped you, Year 12. Thank you for listening.